This seems like a good moment to have a little bit of a deeper examination of strings and characters. We've been using strings and characters now for some chapters, and we are pretty comfortable, I guess, with some of their uses. But I'd like to go into a little bit more detail now to give a more solid conceptual understanding of both strings and characters, and to show you some extra library functions that are available to help you using such things. We'll begin with strings. The only things that I've shown you now so far for inputting and outputting strings are printf and scanf. However, there are many more functions available in the standard C library than just printf and scanf. I'm going to show you a couple of them. I'm going to show you some of the common ones. Now, scanf, you'll remember, is, well, it's somewhat complicated. We've got to use, if we want to use a %s, then it will only read in one word. If you put a space, then it will skip that. Remember that stuff? And if you needed to read in an entire line of code, all the way up to a new line, then you had to use that horrible % bracket, up hat, \n, close bracket, all that stuff. It was really quite awkward. However, there's a much simpler function available called getS. You really just say, get me a string, read a line of text, one entire line of text from the keyboard, and it stores it in the string that you specify. It's a very, very simple function. And also, I should mention that it's actually much more efficient than scanf. Scanf is a large and powerful function. It can do many complex things. You only have to look at the manual page or the reference page for scanf to find out all the things it can do, and you'll find out it must be quite powerful and complex. And so it is correspondingly a little bit inefficient to use such a powerful function just to do such a simple idea. There's a much simpler function available. It's called getS, and I'll show it to you in just a moment. Correspondingly, there is a putS. If all you're trying to do is get a piece of text out onto the screen, and you don't need to worry about %ds or %s's or anything like that, you don't have any particular integers or floats or characters from variables that you need to output. If you just want to output a piece of text, you can use putS. Much, much faster, much more efficient than printf. We'll look at that in a moment as well. And finally, getS, as we'll see, it's a beautifully simple function, but it has a couple of issues. Issues that can even cause your program to crash. I'm not saying that getS has bugs in it, it doesn't, but it's quite open to misuse. It's quite easy to forget how to use it. So I'm going to show you another function called fgetS, which is a slightly more complex version of getS. It essentially does exactly the same thing. It's only slightly more complex, and it's much more robust. It's much more easy to control how it behaves. fgetS is probably the most commonly used function in C for reading string input, either from the keyboard or from a text file. So I'd like to show you fgetS and show you some examples of its use. Just in case you're wondering, getS and putS and fgetS, they stand for get string and put string and file get string. That's what the F stands for, file get string. The F in scanf stands for formatted, and the same for print. Scan formatted input and print formatted output. Anyway, let's go and have a look at those three functions. This is string.c in the Chapter 7 folder. It's a very, very, very simple program. It just uses some printfs and scanfs to read in and output some strings. Now I want to change this program to use getS and putS. So let's see how that works. Okay, well, what I'm going to do is this. I'm just going to do putS in place of all printfs that don't have a % something in them, like %s or %d. So in other words, that's going to be a putS right there. And this, well, okay, we've got a little problem here, because we can't just do this. We can't just say putS by itself, because putS only takes one parameter, the string that you want to output. And here we're saying, well, your full name is, and then it's going to go and get what the full name is from here. So how do we fix that? Well, we could just leave it as it is and use printf, but I'd like to actually illustrate putS completely for you. So what I will do is I will end the string there, and put another put s and just use name for that. How does that look? Well, we'll see how it goes. Now, when it comes to scanf, obviously we change that to a getS, and we don't need any of that nonsense because we're just getting a string, one single string, and we read it into name. Now, gosh, that looks much simpler, doesn't it? None of this silly percent nonsense. If we're just dealing with strings, we can just do that. Okay, so let's try that. Let's see if that behaves itself and does what we want it to do. Compile, no errors, and run. Oh, hang on, there's a little bit of a difference here. We've got a blank line going on in here, and oh, we've got a carriage return after the colon here. Okay, well, we might be able to worry about what. I might be able to look into that in a moment. Here's into your full name, Mark Virtue. Your full name is Mark Virtue, and Mark Virtue is on a line by itself. Okay, so what's going on? Well, what's going on is that puts does an extra thing for you. It puts a new line on the end of the string that you give it and prints out the whole lot. It doesn't actually add it to the string remains unchanged, but it outputs your string and then it outputs a new line character as well. And maybe I don't want it to do that. Well, I don't mind here because here I'm putting out a new line. I could just get rid of that new line and say, well, I don't need it anymore. However, here I would really like the cursor to be sitting on the same line as the colon. So I don't want it to put out a new line. But there's no way to tell puts not to put out a new line. So there is actually a solution to this. We can use a function called fputs. Fputs. I can leave this one as it is. I'll just take out the new line character, and puts will put one in for me. But fputs will not put in a new line character. That's the difference between fputs and puts. There's also, well, that's not the only difference. There's actually a much more significant difference, and that is that you can specify where you want the output to go. And I need the output to go to stdout, S-T-D-O-U-T, standard output. If you've spent some time in the Unix environment, you may understand what standard output is, and if you've only ever worked in the Windows environment, you might not have any idea what that is, and I'm not going to explain it right now. We'll get to that later. Suffices to say for the moment that it is the screen. It goes to the screen, which is where puts sends things by default. Puts will always send something to the screen, so will printf. So when you use fputs, when you use one of these functions that have got an F on the front, you have to specify where it's going to go to. It could go to the screen, or it could go somewhere else that you specify. In fact, it could go into a text file, if you could somehow specify the text file, which we can, but we haven't got up to that yet either. So it's almost the same function as puts, other than you specify where the output's going to go, whereas puts it always goes to stdout, and fputs does not put a new line on the end, which is something of an inconsistency, but that's the way it works. Okay, where else do we not need a new line? Well, we don't need a new line here either, so we will put a stdout there, and fputs. Now we can have a new line after this one, so we can leave that as a puts. It's often good to keep them all the same, like don't use puts and fputs interchangeably in the same program, for no other reason than for style and consistency. They're actually perfectly fine together, but I want to leave them both in this program to show you examples of both. Now let's see if that makes a difference. Compile and run. Oh, okay, that's just looking a bit better. Mark Virtue. Full name is Mark Virtue, and this cursor is flashing on the next line after that, so it did put a new line after Virtue, which is good. Okay, now let's turn our attention to getS. Well, the getS was obviously working. It's working fine. It's working completely fine. But I mentioned that there were some issues with getS, issues that could conceivably crash your program. What was I talking about? Well, okay, here's what I was talking about. Let's have a look at how big name is. Name has room for 20 characters of input from the keyboard. Now, luckily, I only entered 11, plus a carriage return. Just in case you're interested, getS actually removes the carriage return from the string before it gives you the string back. So the string that you get does not include the carriage return that was typed. However, the carriage return is read by getS, which is different from scanf. Scanf actually doesn't read the new line, so you need to flush it away. So you don't need to use flushes with getS, which is very, very nice. It's one of the advantages. So what's the problem? Well, I typed in Mark Virtue. That was 11 characters. What if I had typed in an extremely long name, like, well, my full name, with my middle names in it as well? Mark Jeffrey Wilson Virtue. Now, I don't know how many characters that is, but it's certainly more than 20. Now, what would happen if I did that? Well, getS would blindly just take all those characters, every single one, and try and write them into name. And it would write the first 21 characters successfully into name. And then, let's say Mark Jeffrey Wilson Virtue is 30 characters. The first 21 characters would get written into the variable called name, into here. And the remaining 9 characters would get put, well, they'd get put somewhere. They'd get written to the next piece of memory that was immediately on the stack after name. If you don't know what a stack is, don't worry at this point. So it's going to clobber, overwrite some piece of memory that we have no control over. It's just going to write over some memory. Now, probably what's going to happen is that memory that's been overwritten will contain some vital piece of information for this program, which will now have the word virtue written in it or something else like that. And thus, the next time you come to use that piece of vital memory, it will not work as you expect. And quite often the program crashes. Quite often, because what happens is that piece of memory is often the code itself, or something very closely related to the code itself. So it tries to run as code the word virtue, and it doesn't work, of course. So to summarize, all that you have to do to crash the program is to type in a name that's longer than 20 characters. I mean, you could put out here in the puts, you could say something like 20 chars maximum to warn the user that that's going to crash their program if they type more than 20. But it will not make any difference because the user can completely ignore you and type in as many characters as they want. So that is the main problem with getS. Now to fix that, we need a program called fgetS, which is a little bit more robust than that. So we say fgetS. However, we need to specify more to fgetS than just the string that we're reading in. We also need to do this. We need to specify the number of characters that we can read, 20. Now that's the important thing. That's what stops fgetS from crashing any program. In fact, what happens is fgetS will read in input from the keyboard until it reads 20 characters, and then it will stop reading input from the keyboard. Isn't that nice? So it won't ever write more than 20 characters to your string. Actually, I'm lying to you just a little bit. You need to put 21 there. 21, not 20. Now, I did that deliberately because I want to just keep reminding you about this null character that keeps getting in the way. The question you've got to ask yourself, if you can't remember this, is does fgetS add the null character to the end of the string? I mean, it obviously puts a null character on the end of the string, but is that null character included in the 20 or is it not? In other words, does it read 20 characters from the keyboard and then put on a null, or does it read 19 characters from the keyboard and then put on a null? Sorry, if that would be the question if you had a 20 there. Does it read 20 characters and then put on a null, or does it read 19 characters and put on a null? And the answer is it reads 19 characters and puts on a null. So it will always make sure that it never writes more than 20 characters exactly if you put a 20 there. We've got 21 characters to play with. We've taken room for the null as well, so we can do that. So fgetS will read 20 characters from the keyboard, then put on a null, making 21, and that is exactly the behavior that we want. Sorry, I know that was a little bit roundabout, but I think we got there eventually. Finally, just like fputs, you need to specify the file descriptor. I don't know if I mentioned that before. I don't think I did. That thing there is called a file descriptor. And we need to put one here too. Now, stood out, I mentioned to you before, usually represents the screen. Usually represents the screen. And yet we don't want to read in information from the screen. We need to read in information from the keyboard. And the keyboard, you've probably seen this before, even though you didn't realize it, is stood in. How many of you knew that I was going to type that? Okay, so we're using fgetS here instead of getS. It's only slightly more complex, but you, the programmer, are in more control because you get to specify exactly how many characters get read from the keyboard. You also have a bit more control here. You get to specify where that information is coming from. If you had a text file, you could read from a text file, which is also very handy to be able to do that. As you can see, fgetS is then quite a complete and sophisticated program. You obviously still have to get this number right as the programmer, or your program might still crash, but at least now the user can't mess it up. There's one final difference between fgetS and getS that I need to mention to you, and that is the interpretation of the new line character. getS removes the new line character for you. It gives you back the contents of the string that don't include the new line. fgetS, however, does not do any such interpretation. Just like there was a similar difference between putS and fputS. fgetS does not do any interpretation on the new line at all. It gives you the new line character as part of the 21 characters. So if someone typed in the maximum they could possibly type here, they would be typing 19 real characters, then a new line, and then a null, and that's all you could fit into name. So we've actually changed a little bit here the limitations on our system, and for that reason we may decide that we need to change this to a 22, and obviously then this to a 22, to allow for exactly 20 characters of name to be typed in. It's probably worth testing this. Let's see that we get exactly the right number of characters. So let's just go and compile and test. Please enter your full name. Okay, they need 20 characters, so I'm going to type in the 20 characters like this. So that okay, now that's exactly 20. But what if I typed a few more? 1, 2, 3, 4, 5 more. What would I get? Where would it stop? Before I press enter, have a think about what you're expecting to see. Okay, I'm going to do it now. Press enter. Okay, how many of you thought that I would get a 0, 1 on the end? So I've actually got 21 characters. What about that new line that I was talking about? Well, when you think about it, the new line is actually out at the end after the final 1, 2, 3, 4, 5. So I've actually typed in 26 characters, including the new line, and it's given me the first 21 of them because I told it that it could have 22, including the null. So it gave me 21 plus a null. If there was a new line character there, then that would have been included as well in the 20. If I'd typed in 1, 2, 3, 4 up to 0, 1, 2, 3, 4 up to 0, and then press new line, then I would have had a completely full string with a new line on the end and a null on the end of that. I know this is a little bit complex, especially to do it via talking, but I think you get the general idea. So before we go, let's test it one more time. And we'll just type in Mark Virtue. Your full name is Mark Virtue. Now look, there's an extra new line's been thrown in there. Because remember, putS adds a new line to whatever output it's giving. And this string over here, Mark Virtue, has been read in with a new line on the end of it. And that new line is still part of the string. So name contains a new line. So we print out Mark Virtue and then a new line, which is part of the name, and then putS puts another new line on the end. So what do we do about that? Well, one solution obviously is to use fputS, which doesn't put a new line on the end. But I think it would be more appropriate if we actually removed the new line out of the string name, because it just doesn't belong there. So how do we do that? How do we remove a new line? Can you think about it? Pause the video right now and just have a little bit of a think about how you might do that. Because I'd like to show it to you, but I want you to think about it first. See if you can do it. Just a little temporary exercise. See if you can do it. Okay, well, I'll show you how to do it. Okay, I'm going to invent a new variable called len, or length, and we'll do it like this. Immediately after we read in the name, I do len equals string of name, so I get the length. Once I've got the length, I can write this code. Name of len minus 1 equals that. Now, that's the null character. I'm putting in a null character into my string. Where am I putting it? Well, I'm actually overwriting the new line character with a null character. And how do I know that I'm overwriting the new line character? Well, the new line character must be the last character in the string. It has to be. It can't be anything after the new line character. So let's assume that someone typed in Tom, T-O-M, and then a carriage return, new line. So there's 4 characters in the string plus a null. So len will be 4, because len, if you recall, includes the string function includes the carriage return. The only thing it doesn't count is the null. So len is 4. Now I want to remove the new line character, so 4 minus 1 is 3. So if I put 3 in the brackets, 0, 1, 2, 3, I'm removing the 4th character. Might sound a bit weird, but you can follow this if you try. I'm going to be removing character number 3, which will actually be the 4th character. So I'm going to be removing the 4th character. If they typed in TOM and then a new line, then the 4th character is the new line. So I'm going to be overwriting the 4th character with a null, overwriting the new line with a null. So I'll actually have a string, or at least I'll have an array, that has 2 new line characters in it. One that fgetS put there, and one that I'm putting there manually. So I'm shortening the string by 1 character. Not a bad technique to use. There's only one problem. What if they actually typed in so many characters, like 30 characters on the on the keyboard, and there isn't a new line character in that string? Well, actually, before I forget, we want to flush any other characters out. Like if they typed in 100 characters and we're only reading 20, we want to flush the rest. Okay, so that flushes the rest. So where was I? Yes. So imagine if they typed 100 characters on the line, and I read the first 20. So the 21st character is not going to be a new line. It's going to be the 21st character that they typed. So this will actually overwrite that character with a null. Is that what I want? Well, that sounds reasonable. We've told them they can only have 20 characters as a maximum. We've told them that. And all I'm doing here is ensuring, if you think about it, that the 21st character is going to be a null. In other words, there's only going to be 20 characters in the string. So even though we're actually capable of storing 21, when you think about it, up here we could possibly store 21 if we needed to. We've told them that we only want 20, so we're going to enforce that there's only 20 by setting the 21st character to null. You've just always got to consider these special cases. You've always got to say, well, what if they entered this? Or what if they entered no characters at all? What if they just pressed enter? What would happen then? Well, let's think about it. If they did that, then string would be what? Well, the length, the string would be 1. There'd be 1 character, which would be the new line character. So this expression here would equal 0. 1 minus 1 equals 0. So name 0 gets set to null. So the very first character in the array gets set to the null character. Sounds like an empty string to me. Sounds like a string that's got no characters in it, which is exactly what they typed. They typed nothing. All that we did was we ripped out the new line character by overriding it with a null. So all of it should still work. Let's test it. No errors. And Mark, excuse me, Virtue. Full name is Mark Virtue. There's no extra new line there. Can you see that? The cursor is flashing 1 line below. Okay, let's try the final test. Oh, 2 tests. We'll do 2 tests. I'll enter nothing. Your full name is nothing. Excellent. So that worked as well. Finally, run it again. Time to all the way up to, let's say, 25. It should stop after the second 0. Ah, isn't that lovely? So it's working perfectly. Okay, I'm going to save that as string.c in your Chapter 7 folder, and let's move on.